to interrupt you. You're doing such a good job of huddling. What I want to do, though, is I want to have us have a model so we know what to do. And then you're going to get to choose whatever shape you want and try to prove it. So there's a couple things before we start. This is another thing I learned from your test. On your test, there were several problems where the vertices were labeled, and people would talk about angle C. So why might that be a problem? Why might that be a problem? Sage, why?
There's more than one angle C.
How many angle C's are there?
2.
Are there? There's 3?
How? It's like there's just 2.
3? Okay, so here's an angle C, DCA, ACB, and where's the third one? Yes, exactly. So what you're going to need to do is be really clear about which angles you're talking about. All right, so this table 5 has volunteered to walk us through this. I think in order to, normally I would have you up here writing, but in order to expedite the time so everyone has time to get started, I'm going to record for you. Now, the rest of us are going to be sure we ask them a question if we don't understand. This is a very hard thing to do, really, because if we don't understand something, we think it might be us, like we just don't get it and we're the only ones that don't get it. And that happens a lot in math. But I want you to, so I'm going to have you stop periodically and talk about what the group has said and see if you agree with it. All right. You know what? Maybe I should have you come up and do it. You're as fast as I am. So who wants to start? Drew, you're going to start? Okay, thanks.
I'm going to rewrite it. Should I just rewrite it? No. Actually, I have to.
This would be E.
Andrew, this is hard to write with your back to the whiteboard, but can you try to do that?
I'll try.
Okay, thanks.
So first is triangle C, E, D, current triangle. Give myself enough space. A, E. That's because of side angle side, because you have this angle and this angle are congruent, and then side 1, angle 1, side 2, and side 1, angle 1, side 2. So then, you know that this angle is congruent. So you have angle CTC.
Would you read those out loud for us so we can hear you?
Which part out loud?
Just say angle.
Angle DCE is congruent to angle BAE, which I also marked on the parallelogram. And because of CPCTC, which I proved earlier. And then because these two are congruent, you know there are alternate interior angles if you use AC as a transversal for lines or segments, sides, whatever, AB and DC. So AB is parallel to DC because of alternate interior angles. And then you have triangle BEC, is congruent to triangle DEA. And that's also because of side angle side. So it's side 2, angle 2, side 1. And then over here it's side 2, angle 2, side 1. And then, you know, because they're congruent, their corresponding parts are congruent through CPCTC again. So then you have angle EAD is congruent to angle ECB. Oh no, I used a different one. Oh well. I'll just remark. Anyway. So it's the CPCTC. And then again, because of alternate interior angles, you can use AC as a transversal for sides AD and BC. So you have AD parallel to BC through alternate interior.
So what I'd like you to do now is talk in your groups about the flow of logic through Drew's proof, and is there anything missing? And so, yeah, you can go back to your group, Drew. Thank you. Would you please talk over? What do you think might be missing, or is it perfect?
They said they did it in a longer way. But how do you do it in a longer way? Does that mean you have to prove every single triangle is congruent?
No, if you have both the parallel, as long as you have two pairs of parallel sides, then it's a quadrilateral.
Didn't we label the angle wrong on number 5?
Some of them aren't corresponding.
Shouldn't it be ECB, not BCE? It should be like BCB.
When we get to like contact, I don't know about Is there a shorter way to do that?
I don't think so. As long as you prove two triangles are congruent. I mean, no.
Two pairs of parallel sides.
Yeah. Sorry. It's okay.
What if you... Hey, Ariel, what if you proved triangle DCB and triangle BAD? Then can't you just do it in 3 steps?
That's what I thought you guys were doing at first.
I don't know.
But how would you prove it?
Then you have to use like the addition property and stuff to make sure that DE is congruent, or DB is congruent to AC. Wait a second.
DB is congruent to itself.
Wait, I'm looking at 2. Wait, which triangles are you trying to?
DCB and DAB.
I was looking at CAD, DBC, and AAB. So,
Actually, you couldn't do that because you wouldn't have a second side or a second angle.
Use the other 2, and I think that's what he did, didn't he? Yeah, so he's okay. He used the same angle, but he used different sides of it.
Exactly. He used the same transversal, but different sides of it.
I see, yes. He used the same transversal.
It's just like our proof, it's just ours is like
Really long.
ours is really long.
Okay.
Yeah, I think Jay, I think we should use 2 columns. We can prove it like when you're talking in like paragraph, but then like that's it. When we're writing it down like this because it's a lot shorter. Wait, Miss Humphreys? Miss Humphreys? Do you think if we do 2 column, we have to write like given, all that stuff?
Well, really nothing is in D.
Wait, because Miss Humphreys, if we do a 2 column proof, do we have to write like 2 sides of opposite, or 2 sides of parallel?
Actually, you couldn't.
2 opposite parallel sides. Do we have to write given all that stuff?
Did you think something was missing?
See, then